Chapter 5, Section 5.1 and 5.2, exponential and logarithm functions. First, you need to understand the difference between these two equations. One is x to power of 3 versus y equal 3 to power of x. Functions such as this, base is your variable and exponent is a number. And then the other one, exponent is a variable and base is a number. That's why we call these exponential functions, because exponent has a variable. Like, let's say you have an equation like this, 2 to power of x plus 1. See, power has a variable in it. But the other one, like 5x3 plus 2x2 plus 3x, equations like that, the power is just a number, but base is a variable. So this is exponential function. This type of functions, a has to be greater than 0. So it could be, and not 1, because if it's 1 to power of any number is always 1. So like 1.5, 1.2, 2, 3, and so on. And we show you some of them here. 2 to power of x, to power of negative x, and so on. And these are some good examples, like these two functions, 2 to power of x, 4 to power of x. They show you how to graph it. So when you graph it, it doesn't matter whether the value of x is negative, 0, or positive. When you raise these numbers to power of positive, 0, or negative, the outcome is always positive, means the y value is positive. Since the y value is positive, your function is always above x-axis, because this is where all the positive y's are. Negative y's are here. So these two functions do not go below the x-axis, because y is always positive. This is another example, 2 to power of negative x and 4 to power of negative x. Again, if you notice, when you substitute any number for x, whether it's a negative, 0, or positive, the value of y is always positive. Domain is the x value. So this graph, x goes all the way from minus infinity to positive infinity, the value of x. But y value does not go beyond x-axis. So y value is always positive, because the negative y's are here, right? So range is the y and domain is x. Domain is from negative infinity to positive infinity. Range is from 0 to infinity. Means range has to be positive in this case. Function is increasing. Y-intercept is when x is 0. So it doesn't matter what the value of a is. When you substitute 0 for x, a to power of 0 is always 1. So this type of function, a to the x, the y-intercept is 0 and 1. Same thing here. And then this is an example how to solve one-on-one functions. 9 is 3 to power of 2. Think of this. Let's say we ask you to solve this equation. 3 to power of x is equal to 9. You understand 9 is 3 to power of 2. In that case, x is 2. So if you have equations and both sides have even base, if the bases are equal, then you could set the numerators equal to each other. So x equal 2. So that's why here, 2 is equal to x plus 1 because bases are equal. This shows the transformations that if it's 3 to the x, what's the difference between this one and x plus 1? X plus 1 is you have to shift the whole thing to the left. It's always opposite of what you have here. If it's a plus 1, it's negative 1. This is just the transformations. But solving the homework, you could actually plot some points rather than going to the transformation. And then, you know how in geometry we had pi equal 3.14 and there was a bunch of other numbers? We also have something very similar to that, which we call it E, Neperian number, which is 2.713. It's just a number that doesn't end, E. So you have that function here. This is a number. It's almost 2.7182 and never end. And now you want to graph e to the x is like 2.7 to power of x. In that case, when you want to put some numbers, like for instance, if you ask you to graph e to the x and you put some value for x, let's x equal, when x is 0, e, which is 2.7 to power of 0 is always 1. When x is 1, e to power of 1 or 2.7 to power of 1 is 2.7 and so on. And for that, calculator also has e to the x. So here you have it. You have, if you go to the second, and this bottom here is e to the x. Let's say I want to find, here they have e to power of, let's see, e to power of, let's find a number. You want to find e to power of -2. You know the answer is this, 0.135 e to power of -2. So here you have to put the power, again, I'll do it again. Second, and then here under ln is e to the x. Oh, so, sorry. Second, e to the x. Now for the power, we want to put -2, right? So -2. So you have e to power of -2, which is 0.135, and that's what you have here. So you could practice on this one. And here is the formula that we use for the homework is principal. When you put some money, deposit some money in the bank, this is A is your principal plus the interest, R is the rate, N is how the bank treat your money, whether interest rate is quarterly, is it monthly, or yearly, or daily. You are using this formula. This is one of the most familiar examples of exponential growth in investment earning, continuously compound interest. We have two types. If they say compounded per year, you are using this formula. If it's continuous compounding, they'll be using this formula. So it's based on what they are asking in the problem. Like here, you invest 12,000 with rate of 3%. This is R. Find the balance after 5 years for each of this. When it's quarterly, and it's 4. When it's monthly, and it's 12. Okay? And then if they ask you to do it, use the formula for continuous, then it's this. P is the principal, how much money you deposited first. R is the rate, which is 3% or 0.03 after 5 years. So this is for formula for that. All right. So on the homework, first here, they just want you to practice how to take 0.3 and raise it to power of 1.6. When we ask you to tell which one of this is graph of that, the best thing is to just put some numbers, as I show you here. I put 0, x is 1, and there are 2 with these conditions, but then I put x equal 1 here. 3 to power of 1 is 3. So I'll just come up with 3 points and see which one has that, which is this one. And one thing you need to remember that here, the graph, this graph would not intercept x-axis. It goes all the way parallel to the x-axis, but it never touch. It goes all the way and parallel to the x-axis, but it doesn't intersect. It doesn't intersect it. Okay, so if this is your x, let's say the graph, it comes and goes parallel to this one. Sorry, goes parallel to this one. Okay, it doesn't intercept it. It's not like this. It does not intercept. It's just a parallel. In that case, x-axis is the asymptote. Asymptote is the line that your graph comes and stay parallel to that one, but they never touch. They're just parallel to each other. And that's the case here. And I put it here. X-axis is the asymptote. X-axis is the asymptote. Same thing, we just put some numbers here. We plug some numbers. All these problems, but this one, they just tell you, okay, if this is the x value, what is the y value? You just need to use your calculator. And there is also a formula. Anytime you have a negative power in algebra, if you want to change it to the positive, you reverse it. Like, what is 6 to the power of minus 2? 1 over 6 to the power of 2. See, 6 to the power of minus 2 is 1 over 6 to the power of 2, or 1 over 36, which is that number. Like here, 1/3. 1/3 is 3 to the power of negative 1. And then when you have more than one power, you multiply. So these two base both are equal. Minus x is this 2, x is negative 2. This one, actually, I use the calculator for this. They are saying that take all these numbers. You could do the hand calculation if you want. They're just saying take these numbers and substitute for the x. But if you want to use graphing calculator, I show you how to do it here. I think I have it in this one. So you go to y, put your equation there first. So you go to y equal, which is this, put your equations. Then second window, you see that window here? You put second and then window. That is tables here. So second window, okay? So when you do that, make sure you have all these. The light doesn't let you see it. Make sure everything is according to this. Ask auto, okay? And then second and then tables. And then, I'm sorry, then second graph. Second, and then graph. So any number you put here, like if I input -1, the calculator give me the value. If I put 0, calculator give. If you put points, any number you type here, the calculator would give you a number. For instance, let's say I just go ahead and put, I don't know, 3. When you enter, the calculator will give you the number 12. Okay, so that's how I show you how to use the graphing calculator if you want to input some numbers and you don't want to go through the calculations. All right. So these are all things you could go through this. This is how to use the formula. So each time you put one of these two numbers here, like I show you just one, like here, n is 2, right? So you put 2 here. T is given is 10 years, R is 6%, which is 0.06. And original investment is 1,000. They want you to calculate one. Like for instance, if you want to calculate for 4, then you should put this 4. N is 4. You just, instead of this 2, you just put 4 here and do the. I'll just show you calculation for one of them. The same thing here. Very similar to that, these two problems. And then it goes to section 5.2. You have this formula. If log of x with base of a, then if you want to get rid of the log, then you just take x, take the base and raise it to that. For instance, if I have here, I have log of x base a is equal to, what did they use here? Y, okay? After the LOG, you have this. You write that, you take the base and raise it to what you have on this side. So this is how to write log of x with base a equal to y. You could also write it like this, okay? Look at this example here. They said, what is log of base 1 base of 4? What is that? Question mark. So let's say question mark is x. According to formula, after LOG, what you have in this case is 1. Write that, and then 4 raised to power of x. 4 to power of x is equal to 1. 1 also is 4 to power of 0. So 4 to power of 0, which is 1, is equal to 4 to power of x. So x equal to 0. Another way to do it is this. We also have a formula. First of all, when you ask you to find log of 5, if you don't see any number, means base is 10. If base is 10, we don't normally write it. Your calculator is base of 10. Like if I want to calculate log of 7, and we don't say anything about the base, means base is 7. So all you do is just use a calculator. You just go find the LOG, which is here. Log of, and then what, 7? And that would calculate to 0.845. So if you don't see any base, means base is always 10. But if the base is not 10, it's like calculate log of 7 with base of 3, then you cannot type log of 7 on the calculator. We have a formula. If the log is not 10, let's say you have log of a with base of b, you could write it as log of a with base of 10 divided by log of b. So when we ask you to calculate log of 7 with base of 3, you write it as log of 7, and then you divide that by log of 3. So to calculate that on my calculator, I put log of 7 divided by log of 3, and that gives you the value 1.77. Okay? So this is one of the formula that you need to remember. So again, when we ask you to find log of any number and you don't see any base, base is 10. There is a special case that if your log, let's say I have log of 7, if your base is e, which is what, 2.7, instead of writing log of 7 with base of 2.713, blah, blah, they take this part and they put natural log. So if you want to calculate log of 7 with base of e, you could just calculate ln of 7. ln of 7 means base is always e. Okay, so if I want to calculate natural log of 7, I'll just go here and I say natural log, and 7. And that would give you the value, okay? So natural log is log of a number with base of e. That's what the natural log is. So log of x base of 2, if we ask you to graph log of x with base of 2, To graph this, you could go ahead and put some number for the x and calculate the y value. Let's say if x is 1, then instead of log of x base 2, just write log of x divided by log of 2, right? And then you just put 1 for it. So log of 1 over log of 2, which is 0. Why? Because log of 1 is 0. And like if you put 2 here, then you put 2 here. So it would be log of 2 divided by log of 2, which is 1. Or what you could do is you could use the formula that if you have if you want to get rid of log, what you have after the log here, which is x, you write that, you take the base and raise it to power of 1. Now you could actually graph this function. It's easier to do. Here, you start with y first instead of x. So let's say y is 0. What is 2 to power of 0? 1. Let's say y is 1. 2 to power of 1 is 2. Y is 3. 2 to power of 3 is 8. So it's easier to graph this one versus that. Both are the same thing, but you could, the best thing is if you ask you to graph log equations, you could change it to equation that doesn't have log in it, and then you start with y value and then find the x value. Again, the domain, see, domain is all the x start from here, okay, goes all the way here. X is always 0 to infinity. So in this case, the asymptote is the y-axis. Range is the range is y value. Y is from here, negative infinity to positive infinity. You want to make sure that a number you put after the log, whether it's log or ln, shall not be negative, right? When I ask you to find log of negative 12, calculator would give you the error. Or log of minus 3, calculator will give you error. Natural log of minus 5, error. Number after the log has to be positive. Otherwise, when you use the calculator, what you get is the error. So in that case, what we do is you want to make sure what you have after the log is always positive. So x minus 2 has to be greater than 0, not even equal, greater than 0. So x has to be a number greater than 2 all the way to infinity. Okay, like here, what's the domain? Domain is the x value. What's the domain? 2 minus x has to be greater than 0, 2 greater than x, or if you multiply both sides, x is less than 2. 2 greater than x means x is less than 2. Okay, so that's the domain. x2 equal to 0. The only number you cannot substitute here is, you could put any negative number because negative number to power of 2 is 0. So after ln, you always have a positive number, but you cannot have 0 because natural log of 0, if you use your calculator, is error. So all the numbers except 0, you cannot put 0 here. All right, so and then that brings us to the homework. I think most of the homework here is first, I'm using this formula. I think you should be able to understand this. Anytime you want to get rid of log, what you have after the log, you write that first and then a raised to that number. One of the property of the log is this. We use that for these problems. And also the formula I told you. Another formula is if you have 2 log equal to each other and both have the same base, what you could do is just cancel the log. So what you have after this log is equal to what you have after the second log and solve that. Like example this. What is log of 7x plus 1 equal log of it? How do you solve that? Log and log cancel. 7x plus 1 equal to that, and then you solve this equation. This is look at example 5. So all these problems, I think, should be able to figure this out. To find the x-intercept, you always set y equals 0. Okay. So that y is f of x. So you have this. You have y equal log of x with base of 2. Or x, what you have after the log is base raised to power of y. So 2 to power of 0 is always 1. So when y is 0, x is 1. That's the intercept that you have here. That's the x-intercept. Again, we are using that formula here. That formula also, any formula you have for LAG also work for LN. There's no difference. It's just you're using different functions. Okay. Okay, so that would be, I think the other ones are all graph. You should be able to do it. It asks for the domain. What is domain? What you have after the ln or a log always has to be greater than 0. That's the domain. Okay, so that would be either 5.1 and 5.2.